Every year, the DUT racing team builds a car for the Formula Student Racing Competition. And every year, the aim of the DUT racing team is to continually improve the design of the car. But the car won't move without a driver, and the more comfortable the driver, the better his performance. So how do you design a racing car cockpit that is as comfortable as possible? To design this cockpit, the students deployed their knowledge of ergonomics. This was taught in the ergonomics course of the Faculty of Industrial Design Engineering in TU Delft. If you want to design an optimally comfortable cockpit for the driver, there is a lot you can look at. Most importantly, the driver needs to fit inside the car, so you need to ensure that the dimensions of the cockpit match the driver. In this movie, we will focus on the cockpit dimensions. How do you design a well-dimensioned cockpit? Like all good design projects, the 2012 DUT racing team started with an analysis of the situation. They looked at what the driver does, which parts of the car are involved in these actions, and what boundary conditions need to be taken into account. And because they are developing a next generation car, they asked the previous drivers for their experiences with the cars and for their recommendations for improvement. Let's take a closer look at the actions of the driver. First of all, he has to get inside the car, and at some point, he has to get out of the car. So the entrance of the cockpit needs to be wide enough to allow the driver to get in and out of the car easily. Once in the car, he has to drive, which means he has to sit in the seat with his feet on the pedals and his knees underneath the front hoop, his hands on the steering wheel, and his head underneath the main hoop and against the head restraint. The driver needs enough space to turn the steering wheel and to see clearly where he is going. The TUD racing car is designed for the design competition Formula Student. This competition has a lot of requirements for the car. The important requirements for the design of the cockpit are: a P95 driver should fit inside the cockpit. There are lines between the main hoop and the cockpit that show the required clearance. There are templates for several parts of the car that show the minimum required clearance. When put together in a 3D picture, this shows the minimum required space inside the cockpit. For safety reasons, the driver should be able to get out of the cockpit of the car within 5 seconds. Not only must the entrance of the cockpit be large enough, but also the space underneath the front hoop should allow the driver to get his legs out fast enough. It is not only the Formula Student competition that sets boundary conditions. The team may well develop some additional requirements. The 2012 team decided that they wanted to keep the center of gravity as low as possible in order to improve the stability of the car. And they decided to fix the position of the pedals, steering wheel, as well as the seat. The drivers of the previous cars are a useful source of information about comfort. 8 of these drivers filled in a questionnaire. It is vital to make sure that all drivers have excellent visibility. Supporting the driver's upper legs, thighs and posterior is important for comfort. You should be aware that the pivot point of the heel is not where it contacts the ground. The transfer of the dimensions of the mock-up to the digital drawings should be done carefully. And the driver's clothes limits movements. So take this into account when designing the available space. To summarize the analysis phase, you know that the driver sits in the car and has to be able to reach the pedals and steering wheel. He also needs to be able to see where he is going. You also know what boundary conditions are set by the competition and the team, and you know what drivers would like to see improved. The next step in the process is to collect dimensional data from the drivers. From the analysis phase, you know which dimensions of the drivers you need to measure, and that you have to find out more about the comfortable range of motions of the driver's joints. The dimensions of the driver that determine the dimensions of the car are the eye height when seated for the driver view, the length of the torso for seat height, the length of the legs for the distance between seat and pedals, the length of the upper and lower leg for the clearance needed to get in and out of the car, the lengths of the arms for the position of the steering wheel, the width of the hips for the width of the seat, and the width of the shoulders and across the elbows for the width of the cockpit. So now you've got a list of all dimensions that you need to measure from your team of drivers. But as they will be dressed in their racing clothing, you need to measure them dressed in this outfit. Now you know what the dimensions of your drivers are, but will a 95 percentile stature driver fit? You may look up the dimensions of this driver in the DINED tables, but you do not know how much extra you need to add because of the racing clothing. A way to solve this problem is to measure drivers with and without their racing clothing. This gives you an estimation of how much you need to add to the DINED data. When a driver sits in the car, not only the dimensions of the body are important, but also the posture. This means you will have to look for information about the comfortable ranges of motion of the joints. For the legs, you need information about the ankle, knee, hip. For the head, you need to know the comfortable position of the line of sight and the comfortable range of motion of the neck. For the arms, you need to know the comfortable ranges of motions of the shoulder and the elbow. After you have gathered the necessary information, it's time to start developing concepts. This is not a linear process, but a cyclical one. Each decision made for the position of a part of the car will influence the position of the other parts. The goal of the concept development process is to find the optimum position and dimensions of all parts of the cockpit. A starting point for the concept phase is the decision that all elements in the cockpit should get a fixed position. One size fits all. To find out where to put these elements, there are three possible approaches. You could start from a fixed position of the eyes, the so-called eye reference point. You could fix the feet. This is called the feet reference point. Or you could go for a fixed position of the hip. This hip reference point is what we will use here. The team made the decision that the center of gravity of the driver should be as low as possible. The ideal position would be lying down, stretched out in the car. It will be clear that it is impossible to drive the car in this position. So the first step is to decide how far the torso needs to be rotated to get the eyes into a position so that the smallest driver will be able to see the road. When he can see the road, the tallest driver will be fine. This position of the driver gives you the lowest possible position of the top of the front hoop. The next step is to decide where you want to position the pedals. These should be within reach of the smallest driver. When you position the pedals at the extreme reach of the smallest driver, what does this mean for the position of the tallest driver? Does he still fit underneath the front hoop? And what about the position of the feet? What ankle angles are required to press the pedals in this leg position? Do you need to adjust the angle of the pedals? It will take several cycles to get at the optimum position of the pedals. After you've made a decision about the position of the pedals, you need to check the position of the torso. You need to look at the position of the front hoop. Is the lowest position of the hoop still possible, or do the drivers need more space underneath this hoop, and did the hoop get higher? Now you've decided the angle of the backrest and the position of the pedals, it is time to look at the steering wheel. The driver uses his arms to steer the car. This is more complicated than the torso and the legs because the arms are moving. You need to look at the extreme positions of the arms as well as the space the arms need to move. The steering wheel should not block the sight of the driver, therefore it should be underneath the front hoop. The driver should be able to reach the steering wheel, so it should be within reach distance of the smallest driver. But the driver needs to be able to turn the wheel as well, so the wheel should not be too close to the largest driver. And the driver needs enough space for his arms when steering. This space is limited because of the room needed for the batteries. Taking all this into account, you have to make a decision for the position of the steering wheel. When you have done that, you have to check the position of the torso and the legs again. Do you have the optimum combination for the position of the driver, or do you need to make further adjustments? You might need to go through this cycle several times. In the end, the result is a decision for the position of the seat, the pedals, and the steering wheel. So far, you have designed the cockpit based on literature and human models. This will take you a long way, but you are missing something. What does it feel like? To get an answer to this question, you need to build a life-size mock-up to test the design with drivers. They will give you the feedback you need to make the final adjustments before you actually start building the car. The mock-up also helps to explain to the cockpit engineers that you really need that much space or a particular position of the elements in the cockpit. At the end of all the discussions and the decision making, you get to building the real thing. So just go for it.